Hello, fellow humans.
Well, welcome to the Rise of Humanness podcast, where we explore what it means to stay human in a world increasingly run by algorithms, bots, and machines. I'm Mike Schindler.
And I'm Chris Nolan.
And together, we're going to show you how to stay absolutely powerful.
Stay human.
The rise of humanness in the age of AI. It's a podcast with Chris and Mike. The rise of humanness in the age of AI. Stay curious, stay human, let's rise.
Hey guys, Mike and Chris here again with the Rise of Humanness podcast. We're so excited to have you guys back on the show. You know, this is the podcast where we really explore humanity in a world that is becoming increasingly run by machines. It's just crazy what's going on in the marketplace. And so today we're going to tackle some pretty big questions. And this is, Chris, I got to tell you, this is kind of like the holy grail.
Game changer with Mr. Jamie Gorman.
Yeah, no, I love this. I can't wait for our audience to be Jamie. I mean, this is just going to be so great. So we're going to talk about what happens when you kind of marry psychology, robotics, AI, and we kind of all join hands and we say kumbaya.
Yes. Will it be a buddy movie or iRobot?
Which I think Jamie Gorman, welcome to the show. I think he'll be able to answer this question because Jamie, so you're the director of ASU's Center for Human Artificial Intelligence and Robot Teaming, also known as CHART.
Yes, the famous CHART.
Yeah, so welcome to the show.
Welcome to the show, Jamie. Great, welcome to the show. Like Mike said, so this entire show is really about AI and HI, human intelligence, which is your field. And as we said, we feel that places like CHART, which is CHART open source?
Yeah, CHART is actually a center under the Global Security Initiative at ASU. And ASU, like any university, they have different strategic initiatives. And one of them is the Global Security Initiative. So we do a lot of work with the Department of Defense, for example, to help humans work with machines to promote security in the US and around the globe. So that's the main focus of what CHART does. However, we can get into this more, but some of my work also gets more into the K through 12 educational system within the US, so less DOD related. But the ideas that we develop and the technologies that we're working on have applications in many different fields. But yeah, primarily CHART is under this DOD sort of global security initiative at ASU.
Awesome. That is crazy. Okay, so Jamie, you go K through 12 and then this big mothership of DOD, which is crazy. I guess it's probably
the big to the small, right?
I mean, I guess it's both managing cats. You know, you got DOD and you got classroom settings. But Jamie, tell us a little bit about you before I really dive into some of this stuff, because it's fascinating. Well, how did you get started even in this? Like, you just woke up and said, I got tired of playing with Legos and you wanted to do this, or what?
I got kind of sucked into it due to the applicability of my research to this area. I'm a psychologist. However, my background is a little bit different than what most people think in terms of psychology. So I started out studying teams of humans. So you could think of operators controlling an uninhabited air vehicle, but they have to work together to navigate and position the vehicle to take reconnaissance photographs, things like that. But, you know, when you start extending this out to the view of the system, and I'll just say human machine system, it could be AI, it could be robot, but out to the scope of the human machine system, then we bring in the UAV example, the UAV is part of that team as well. So how do we study teamwork at the nexus of interaction in these systems that are meaningful both psychologically to the human and meaningful in terms of system performance to engineers, developers, stakeholders in these systems, right? And my work gets directly at measuring those interactive states in these human machine systems. And that's really where the human machine teaming comes in. Teaming is just one way of looking at that interaction. There are different approaches for studying human machine interaction, but mine is unique with this teaming element.
Since you're a psychologist, let's go a little bit deeper, really getting into it. So the Rise of Humanness, our podcast, isn't just about human augmentation. We call it human ascendance, okay? And what that means is, and why we think what you're doing psychologically for the brain, finding out cognitively how things are changing, finding out how our well-being is changing, finding out how we get into flow states as group. The idea is that if we really understand this, we'll understand not just how humans collaborate seamlessly, but how they flourish in the robot AI world. So talk a little bit about how exactly do you measure teamwork between a human and a robot?
Yeah, I can get to that point by giving some background first, because that point about the rise of humanness, that's critical in my work. So I think the way things are typically done, the way I would describe it, is machine systems are built as a closed system and humans are studied as a closed system. Then we try to put the two together, right?
Oh,
So that's closed system engineering. Open systems engineering is where we actually develop these technologies with the human in mind from the outset, and how they are mutually going to impact each other, the technology and the human. So when I say closed system, that applies to psychology as well. And there's a lack of humanness in psychology as well. And I'm talking about experimental scientific psychology. I recently wrote a paper about this, addressing something called the dynamical hypothesis in cognitive science. Okay, so just to break
Those are big words for me, Jamie.
Yeah.
Those
you have to break it down. Do you have a pictograph of that?
I'm gonna you got a color crayon.
Does it have a puppy and a cat?
Yeah. It's actually much simpler than it sounds. So think about two groups. What this paper was about are two groups that have historically, kind of theoretically, been at loggerheads with each other in cognitive science. One group being what are called the dynamical systems psychologists. So they use models based in motions of equation, Newtonian physics, to some degree quantum physics, to understand human behavior and what humans are experiencing. So they are, in my opinion, an example of where mechanical view of the world, of reality, is guiding how we're thinking about human experience of that world.
Oh,
and so that is not the humanness that I would get at. The other side of that I address in that paper is the called the cognitive hypothesis, and that's human cognition is reducible to a computer, a machine operations, right? And so that's very much in line with some current thinkings in AI, as well as traditional thinkings in AI, where AI was more rule-based than neural network-based as it is now. However, both of those aspects of psychology, modeling the human as a computer or modeling the human as a mechanical dynamical system, that is not the humanness, or it's lacking the humanness, I think, to some degree, that I want to bring into these human machine systems. So one example of closed system engineering would be something along the lines of, okay, let's build an AI teammate. I guess I should define what I mean by teams. That was the original question. So traditionally defined by Ed Solis and all, teams are two or more people who have different roles and they have to work together independently to achieve a common and valued goal. So this happens all over life, right? It happens all the time. And so one view of human machine teaming is to have the machine be one of those teammates, a fully fledged teammate. And my colleague Nancy Cook talks a lot about this. And they can work with a human to accomplish that shared and value goal by complementing each other. And so from the closed system engineering viewpoint, what you might do is create a model of what you think the human is expecting, anticipating, thinking. They're called mental models, but you would program this mental model into the machine. And that's going to allow the machine to do things a good teammate does, like anticipate the needs of the other, back them up when they need to, things like that. Where my research diverges from that viewpoint is we study human machine systems directly at the point of interaction. So I'm not thinking about a mental model that's an object in the person's mind or something like that. I'm thinking about the real-time experience of a human working with the machine. It doesn't have to be a machine either. As I said, my research goes back to teams of humans working with each other. Those interactive states are those moments, much like the moment we're in right now, where we're engaged in some productive conversation or teamwork or something like that. But if we can capture those experiences in quantitative ways, which is what I focus on, these measurement systems.
Yeah.
If we can capture those in quantitative ways, that's significant because those relate simultaneously to the human's experience of being in that situation, as well as those what we might consider more objective system performance variables that the developers might be interested in. And so that point of interaction is the key piece of my theory.
That is so okay. So I've got two questions to build off this. And Chris, yes, I did actually keep up with all of this. Believe it or not, I did.
No, you did. No, we know what. So because Mike, because it's about teams, and we do it teams all the time. And he's so right about sometimes psychologically, companies don't even know how, or even they don't know how teams work together.
Well, I think from the military's perspective, we kind of got that figured out to some degree. But
military I guess, more, yes.
Yeah, my question twofold really is, number one, what is the biggest mistake that you see people, making when they design these AI systems to work with humans? That's number one. So is there a big flaw that you see that happens there? But number two, couldn't it be argued that every human is in and of itself a closed system?
Yeah, I mean,
does that make sense? We operate differently. So couldn't that be a closed system or no?
Yeah, I think
you said there's psychology closed systems. Yeah.
Yeah. I think it's how you frame the problem is really where you might draw something off and say, oh, this is my closed system. I don't care about perturbations outside that are going on outside of this particular scope. But that's the issue, though, I think, is treating human experience as something that can be studied closed off from real-time interactions with these technologies, that if we develop some principles of human cognition, that those should equally apply to these contextual situations that we couldn't foresee outside the laboratory. Same thing with the machine development side of it. Closed system engineering might be like, well, let's optimize the system to perform these tests, to perform on these metrics, like speed of operations, accuracy of operations, something like that. But then when you put it out in a real context, it's going to break down because it lacks what humans actually bring to that team, which is dealing with uncertainty, constantly adapting, trying to survive and flourish. That is something that the machine element alone, I think, lacks. Well, I should say the machine element, it can also be goal directed. However, its reward functions, its goal functions have to be aligned with some designer's concept of what the machine should be doing, which may not be the user's concept in the end.
Yeah. Well, so is that what you mean when you talk about you're studying the whole system, both the human system and the AI system? I think because this is what Mike and I deal with, even with our consulting. And this is why there's a lot of these stats about 40% of the people or half the people feel they're overwhelmed by AI, and 77% feel that there are challenges that they can't meet. All this kind of stuff is because we're not understanding that kind of the closed AHI system is what you're doing, which is so great that you're from a psychology background. Now, so what are you doing? What multimodal feedback are you getting? What human interactions? What real time? I know you're probably getting a lot of stuff. Real time decision making, cognitive traits, all kinds of feedback. How are you getting this? Is it with EKG and heart monitoring, and is it also because there's a lot now with human tech and biohacking. Are you guys exploring all those areas?
Yeah, so the measurement systems that we develop are essentially, you start with a sensor suite, which is a combination of physiological sensors, behavioral sensors. So physiological sensors could be EEG, FNIRS, so neurophysiology, as well as more like a heart rate, skin conductance, these sorts of things that are known to fluctuate with stresses on the human. At the same time, we have machine sensors. So with the UAV project, for example, we have all kinds of metrics from the UAV: speed, altitude, heading, is it in a warning state, alarm state? But we have sensors on the machine, we have sensors on the human. So we build a sensor suite. In different projects, the sensor suites can have different amounts of sensors. But in general, think about sitting in the cockpit of a modern vehicle, right? You're driving. There's sensors all over this vehicle, right? There's sensors in the vehicle, so it's sensing the user. It's also sensing what's going on in the vehicle. And that's an example of a sensor suite. But we build sensor suites that are unique to different projects, right? In the case of driving the car, so like a modern, car has all these features like lane keeping, and like if you get in a rental car, this happened to me probably a few times, and you're not used to it, and the wheel starts jerking, and you're not fighting it, but it's a little like, why isn't this thing working with me? Why is it making me steer? I'm doing fine, right? And so that's what I mean. Like that point of interaction, that's an interactive state that the human experiences, and it is also feeding into the performance of the vehicle, right? And there are certain things about that interactive state that we can assess that relate, as I was saying before, to the human's experience. So, for example, influence is a big metric that we can. So, influence is the degree to which the behavior of an individual change the pattern of the system in which they're embedded. So in the car driver, that might be the system, right? On the internet, they talk about influencers. It's the same idea, right? How much are you changing the pattern?
That is so fascinating. I want to build off that a little bit, because you're working with students, you're working with faculty, even DOD experts. So you're working with all these multidisciplinary, individuals, fields, et cetera. You're pulling all this research, you're looking at how the system influences the human, how the human influences the system. So you're tracking all of this, which is fascinating to me. So it's like you're trying to take this holistic approach to this. I mean, Jamie, are you going to come out with some class like Team Building with Robots 101? I mean, is that like the next stage? Like, how do we, because right now it just seems so much it seems so big, like it's almost like we have to start small.
Well, it might be interesting, Mike, to have him, because he was getting in the autonomous cars.
Yeah.
I'd love, from your question, Mike, is to you're giving some great examples, Jamie, of like, how do you work with the DOD? Because that's a different set, like Mike said. And then how do you work with kids?
Okay, yeah. So
I mean, is it 101 for both of those? I mean, that's just,
Yeah, similar ideas across both of those. So I'll start with the DOD because that's my main focus. My work with the kids is through a National Science Foundation AI Institute that's at the University of Colorado, but I'm part of that. But with the DOD, our big thing is developing measurement systems that measure what we've been talking about, the interactive state, and then we put metrics on top of that, like influence. So one example, a project that we have with DARPA, the Defense Advanced Research Projects Agency, so that's a DOD agency. A project we have with them right now is we are developing a biobehavioral team measurement system that, again, has all the sensors we were talking about and does things like in real time calculates the amount of biobehavioral influence between people who are working together, things like that. And ultimately, that piece of technology, and it has AI in it, this is where the machine comes in, that piece of technology is what a human instructor is going to be walking around with on an iPad, for example. And being able to look at these advanced analytics about teaming that would be otherwise hard for them to observe. So think about increased training requirements in the DoD, given our near peer sort of future. What we can do with these systems is to increase training efficiency and enhance training effectiveness by allowing the human instructor to work with this machine to make observations they otherwise couldn't make. And so that's an example of what we do with the DoD. And we've got 3 projects actually we're working on right now where we're developing different versions of that type of system for instructors. Now with the K through 12, so that institute I mentioned, it's the Institute for Student AI Teaming, and it's headed by a good colleague of mine, Sydney DeMello. And what we're doing there is we're developing measures of, we call it dynamic reorganization of knowledge, and that's where we have kids think about kids sitting around a table doing a collaborative learning exercise in a classroom. And I should mention collaborative learning is very team-based. That is the future of education, or one of the pathways in the future of education. That takes a very teamwork-oriented perspective where rather than having the students learn material and then they're tested on that material, or go to a lecture, then they're tested on a lecture, they actually have to get together to build new ideas and new solutions to things like how to engineer a soil sensor is one of the curricula that they have in the institute. And this is thought to tap into more of the types of valuable education experiences that'll lead people to be productive as our society continues to advance. I mean, the human population is exploding, as everybody knows. Yeah. We're always moving forward. And so those sorts of collaborative skills are becoming more and more relevant. Yeah. And so what we're doing in that, yeah. And so what we're doing with that is we're contributing our metrics. So dynamic reorganization of knowledge, the influence metrics, so the evenness of the influence of the students around the table in the conversation, things like that, to collaborative problem solving. And those are going into, or they call them AI partners, but think about like a smart speaker that's sitting in the middle of the table as these kids are around it, solving their problems. And it's sort of tracking these states in real time, influence, how much they're reorganizing knowledge in their conversation. And it's tracking these, and it could do things like put it on a dashboard for the teacher, not an instructor here in the military, but a teacher in a classroom, and help them make those types of insights and observations that they would otherwise miss, because you have one teacher in a classroom full of these tables with kids solving these problems, right?
It's amazing. It sounds like you're building the Starship Enterprise on one side, building the future fleet members on the other. I mean,
maybe we should set the stage by directing things coming out now, because I love what you said, Jamie. I want to set the scene for our audience, because you're going into a company, you're looking at the closed system that is human.
Yeah, that's good.
And you're bringing in, you're looking at that first. Mike and I have this leadership program, which is called VUCA Max, which is about volatility, uncertainty, complexity, ambiguity in a massively accelerating exponential world. So you mentioned uncertainty. So there's all this stuff that people have in the closed system of the teams that you've got to deal with. How do you start there, analyzing where that team is? Where's the leadership of that team? Where's their foresight? How do they work together as a team? So that's one area. Then this is why I want to set the stage. When we talk in robots, everybody's seeing R2D2.
Yeah.
Everybody's seeing or Grok. Elon Musk Grok standing there. So when you're talking robots, you're talking still an AI device that speaks. So it's a bot. But there's also robots that are actual physical robots. Like you said, the car is actually really a physical robot. And there's a lot of machinery, I'm sure, in the military that they use that are actually physical robots. Drone, So kind of set that up, how you deal with both those areas, like the team. What do you do? What do you do first? And then dealing with robots on many different levels. What do you do? How do you work those both together?
Yeah, that's an amazing question. Let me see how I can address this.
I'm gonna mark that, Chris. I think that's the first time we heard that, Jamie.
Sorry, I'm making the movie right now for you, Jamie. We are doing a documentary called The Rise of Humanness. So we're going to have you back, and we're going to set that scene.
Yeah.
Yeah. No, that's amazing. I mean, so going back to that closed system point, I guess, again, like studying the human as a closed system kind of mimics developing these machines, be they robots, et cetera, as a closed system. Like back to my original example, thinking of the human mind as a mechanical or hydraulic dynamical system, or thinking of the human mind as a digital computer, right? That lacks, well, let me say that it has certainty when you think like that. You have an answer to your problem.
Interesting. Okay.
And I think that's where a lot of people go with it automatically. It's like, how can we just be certain about this is the right answer? That's one thing that I argue is like the fundamental axiom of logic is that every question has a true and correct answer. But that's not really human experience, because things seem to always be changing. And so that's where I think viewing the human as an open system comes into play under a constant, like, I don't want to sound too negatively, but to use that term uncertainty, humans are constantly dealing with uncertainty all day, right? Just the mere fact of interaction with other people changes what we're going to do or how we were going to do something.
Well, it's very military. It's OODA loop, right, Mike?
It's the total
Assumptions.
OODA loop. Yeah, it's total
Assumptions.
OODA loop.
Are you familiar with the OODA loop, Jamie?
I am, yeah.
Yeah.
It's a total OODA loop. Yeah.
Well, I mean, it's VUCA, right? I mean, that's exactly what it is. I mean, you're so right, because you're talking about second and third order effects, right? So I might have an idea of what the question I'm going to ask you, but it's different from what you're expecting. And if I change that, it's like in the military, we say there's there's two types of plans that might work and plans that don't work. And your best laid plans, just remember the enemy gets to vote, right?
Yeah,
So
right.
you have to adapt. And I think that's what you're talking about, Jamie, is it goes to, I'm thinking about Interstellar, Chris. Remember where he's like, it's impossible to land on this spinning, out of
the
control.
computer, yes.
Yeah, the computer's like, no, there's just no way this is going to happen. He's like, no, it's a necessity. We got to make this happen.
Necessity.
And that's what you're talking about, Jamie, is golly, the fact that you're bridging that's crazy to me.
We talk about deductive reasoning, Mike, right?
Yeah.
Computers are trained in deductive reasoning. But
Yeah.
Mike and I, in our program, we show that there are actually 10 other types of human reasoning. And a lot of those have to do with things like bluffing and Captain Kirk, overriding
A hunch.
the computer because of a hunch, right?
Yeah.
Or criminals who go around it's all these different types of reasoning that we have that are not predictive.
Yeah, no, I would agree with that.
Well, let's go back to the scene. We've done the humans.
Yeah.
So let's
Okay.
get
So
the
yeah.
machines.
So the other side of that issue, with my experience anyways, as a human, is kind of what we were saying before. Oftentimes I think something will work out a certain way, but just due to the mere fact of interaction, like there's a weird driver and I can't get to where I'm going exactly, it's going to end up another way. But humans are really good at dealing with that uncertainty. So I think the flip side of that constant sort of dealing with uncertainty, adapting, is enormous amount of creativity. And that is not only creativity of action. I mean, call it what you want. Like, you have a plan to do something and it's going to change. There's different terms for it in different areas, like anomaly, mutation, whatever. I mean, but these things just happen, and they're creative. And so that's something that we really try to capitalize on, that brings in, I think, that more open systems viewpoint. So the way we measure things is by thinking about how systems behave whenever there's a living component involved with it. And one of the most basic aspects, so this goes back to Hans Selye's work in the 1950s, he's a physician, on something called the general adaptive response. And this is one of our primary measures that we take on interactive states. And so the general adaptive response, that is whenever something that is living encounters a stressor, it will try to reorganize itself to its best capability to maintain its viability and recover under these new conditions, so that it can stay alive and achieve its goals. That's sort of a thing. But that concept, there's a medical definition for it, but we apply it to all kinds of things. It's very generalizable. So the human trying to reach a goal, and then because of some perturbations or interactions, that changes and they have to get creative and find another way to do it. That is an example of something we would want to measure in terms of an adaptive response, a general adaptive response. It has three parts that we measure. One is inaction, in other words, noticing, or sort of the system becomes aware that some internal reorganization needs to happen to keep it viable. The adaptation, which is the maximum amount of reorganization that the system is going on, or is going through the system in terms of how its components are relating to each other under this condition. And then recovery, and that's recovery to a stable state, because living systems cannot stay in these highly adaptive states. They're just not stable. But at the other part of it, those highly adaptive states where things are reorganizing a lot, they can also be, like I said, creative. They can end up in new ways that we didn't originally foresee. I can give you actually another example that might be helpful.
Yeah.
Okay. So going back to this paper I was talking about before, I use a metaphor for this general adaptive response that I think a lot of people can relate to. So think about an exerciser who's starting to walk and then transitions to running on a treadmill.
Okay, so this is Chris. Okay, keep going.
Yeah, I do elliptical but I experience the same thing. It's very
Uh-huh.
general, this phenomena. So when you start running when you're walking, you're in one metabolic state, right? You're in a one sort of aerobic metabolic state. When you start to run, your body, it doesn't have enough, it's not bringing enough oxygen, and so you're in an anaerobic state. And that's where the energy has to come from inside your body. It's not coming from this exchange and raising the temperature of your body, that sort of a thing. But that transition point, that's unstable. A human body can't maintain that. The anaerobic metabolic system is very short-lived. But there will be a transition point where the runner recovers stability. So they've reorganized into a new state, which is this running state where they're breathing much faster, they're sweating, but they are in a relatively stable new aerobic state, right? And then when they transition back to walking, there's going to be like an oxygen deficit. That's unstable too. And that's where the body is recovering from this running state. But those sorts of dynamics, I'll say, apply to human machine systems that are encountering internal and external stressors as well. And we can detect them, and we can put metrics on top of that, like what is the human experiencing as this human machine system goes through this type of transition.
So what's the end game to all this, Jamie? So you're studying both these systems. Is the goal that they work in perfect synchronicity, or what's the end state? I mean, is it like
and what have you discovered?
Yeah.
Well, I don't know. The end state for me would be, I think there's different goals that I have. One, as it relates to chart, so the center. One is a new science that is not housed in the traditional university laboratories, and this is pervasive in universities nowadays, especially at ASU. But so we could study computer science closed off from psychology. We could study psychology closed off from computer science, and then bring the two together, or something along those lines. But chart is really at the center of a new science, and where I think science needs to go for all of humanity, which is not these carved off classic niches that I'm stuck in this niche, and this is where my theories lay, and this is how I think about the world. But these new approaches that build on what we already know as humans, what our cultures have developed, and think about reality in new ways, and start using those ideas in innovative ways. And so that's one goal for me, is to create this new science that's really not psychology, it's really not robotics or computer science. It's really at the center of all these things, and it's about the human experience and how these interactions with machines can help us, continue to survive and flourish.
The next level, yeah.
Yeah.
I mean that's great. So we'll do another future movie here. So one of the things that Mike and I deal with the Rise of Humanness, he brought it up with that great Interstellar clip, is that, are you familiar with Ethan Mollick at Wharton? He's an AI expert, also teaches entrepreneurship at Wharton. And he says that in this age, which is what's so great about what you're doing, Jamie, that we need more expertise, more coaching, more training in every field to come up above what he calls the 80% threshold of where AI is going to take us all. In other words, if you're 50% capable, you can use AI and you get to 80%. But there's above that, there's a 20%, which is how do we get people to exercise their creativity, their critical judgment, all of that stuff, right? And or get to that 1%. Okay, how do we get people up there? And I'm just going to throw something out, because you're a psychologist and you're into neuroplasticity. Do you think that as you learn more and more about AI and how it puts us into group flow states, for instance, that it's actually cognitively taking us from, like, let's say where Cro-Magnons went from Cro-Magnons to, Homo sapiens, and they grew the prefrontal cortex to another version, a higher level of collaboration? Can we expand mentally?
Chris, can I reframe that? Are you asking, is the question, hey, is AI really going to elevate us as humans and expand our ability?
Well, we have to operate in that 20% sphere now, because AI has democratized knowledge.
Yeah.
So we have to understand what Jamie's working with is he's working with finding that part of where we are, where we use AI as the teammate.
Yeah.
It gets us to a certain level. Then where do we take it from there? That's
a good question. Yeah, that's great. Yeah, where do we go from here?
Yeah, that's a really good question. So
That's twice in one
AI,
podcast, Chris, by the way.
I mean,
You got to say one of Mike's was good. That one that
yeah.
was pretty.
We have a
It's
star.
about four.
So
Yeah.
far, he's got 2 stars, Jamie, and I've got nothing. So it's all right.
Yeah, I mean, I'll use a metaphor. So, time to time, humans create things that revolutionize or change in some significant way how we live in our society. And it's for the purpose of, at least ideally, it's for the purpose of making humanity more survivable, have a better life, those sorts of things. I mean, look where we are on our day-to-day lives and the amount of comfort we have and convenience compared to what 100 years ago, right? And that's not going to stop anytime soon. I think AI is just another piece in that. But where I want to see it going, and I actually, when I was applying for graduate school, I remember my application thesis was about this being on another planet hundreds of years from now that was actually composed of biological and technological pieces, and it didn't view this being didn't really view itself necessarily as something other than an entity that wanted to survive and thrive. And that's how I see these things working together. And that's how I want to see them work together, is to enhance human survival and flourishing, as I've been saying over and over. Now, the best way to do that, I'm not sure. So teaming is one way to look at that interaction that deals with that definition that I laid out before. Like you have two components that provide complementary aspects, but have to coordinate with each other in ways that are satisfactory and effective, right? And that's the lens that I want to see this move forward through, is through teaming, more so than something like just pure augmentation. Like the human doesn't have to understand anything about the machine as long as it can enhance the human's cognitive ability or something like that.
No, I think that's right. I think that, one of the things that I heard a really brilliant way of kind of articulating what AI can do or its potential is that AI creates more Wright brothers moments.
Yeah, didn't I say that, Chris?
Yeah, I said it. Yeah, of course, 60 years later, we're on the moon. Do you know the Wright brothers said, I think, after they got off the ground, they go, this is great, but we'll never get across the Atlantic. So that's your assumption thing you're talking about, where we think, oh, well, yeah, we may be able to take it for short trips, but, we're never going to,
we're never going to get beyond the
never going to get beyond the Atlantic. But that's where we are, whether it's in, schools or wherever it is. It's going to give people, as they get above that 80% threshold, more of these bigger moments.
I think so.
This is possible.
Yeah, I think it's going to expand their humanness. So when you talk about teaming, Jamie, are you talking about humans and robots co-teaching in a classroom? Like, is that a teaming example? Like, I'll go into a class one day and I'll have the teacher, like the human side, and then I'll have the robot, the avatar. I mean, is that kind of a teaming environment too? Because they're probably going to teach a little differently, right? Or is the robot always going to be fact-checking the human? I mean,
it could be an avatar too.
Yeah.
Possibly. I mean, there is this vision of how AI should be used in the classroom that completely gets rid of the human teacher, and it's just an AI-based classroom or AI-based learning experience. And that's one viewpoint, and then there's the traditional where it's just the human. But I think where the teaming viewpoint makes a little bit of a conceptual difference maybe is that it's the human and the machine in the classroom are working toward a common and valued goal. So what does that mean? It means like whoever developed this AI or the machine needs to have that teacher's goal, that shared goal in mind from the outset to really make that teaming effective.
That's
more so
weird.
than just a goal of the machine being a teacher, right?
Can you just see where that can go so many weird areas? Like
Totally.
some guys will treat it like kind of like her, right? But they go, oh, I love that teacher.
Totally.
Oh my God, she's really great. And some people make fun of it. I mean, it's just going to be so weird.
I know, but what a cool what a cool time to live. I think.
Yeah.
I mean, it's like I don't know. I mean,
surreal.
Yeah, I mean, the work that you're doing to marry psychology up with artificial intelligence, with robotics. I mean, to me, this is like groundbreaking stuff.
It is.
And it would be So if I don't want my job to be stolen by AI, like if we're talking about this teaming thing, like, so, certainly in the consulting world, the teaching world, the coaching world, things that we do. I mean, even Mia, like Mia's a great coach, right? Like, Chris, you and I test Mia all the time, and she's great. And she even makes me think differently about certain things. Do I need to start learning robotics, or, am I just going to be the guy organizing pizza for the team at some point? I mean, where does this go? Like, if you're advising me, you're like, no, Schindler, you got to start learning robotics or AI, or, you're just the pizza guy.
Well, I'll tell you, my students, I should say, I am a psychologist, but I'm a professor of human systems engineering. That's my academic hat. So
Yeah.
engineering, right? So my students do a lot of programming and computer science type of courses. But what I'm talking about is different than what you can learn in those courses. And that's just like, what's the motivation for understanding these systems and how to make them better? From my perspective, if the human doesn't embrace or trust or eventually come to rely on this machine that they're working with, it's going to die out anyways, right?
Oh, that is the holy grail. Now, let's go to the rubber meets the road with clients, because the reason I said you're a rock star is because we haven't really been able to quantify stuff. I mean, there are some facts. They say that AI tools help workflow 40 to 60%.
Mm.
They say you get a 12 times uplift. They've got some things like that. But let's say we went into a company, let's say as a hypothetical, you and I, Mike and I go into companies, and they say, first of all, we want you to get our teams on the same page, right, Mike? Because they're either
That's what
negative, or
always
they're
starts.
this or that, or they're working off site, or the culture's
Yeah.
a little off. So
Yep.
that's why we're on the same page. That the companies really have to start there. Like, how are your teams working together? Now, what? Let us introduce you to Mr. Bot, Mr. iRobot. And then that's a whole nother leap of how you incorporate this thing into the team. So that's why, and this is like crazy out there now, because first of all, AI is just, as you know, it's like the ultimate no manual.
Yeah, here's a great tool, but with no manual.
It's like I said, do it yourself, figure it out. I know it costs $1 billion to build, but hey, it's just something for you to play with. So that's crazy. So what's the quantifiable stuff that you would say to a company? Work with us, and we're going to deliver X 10 times more, because I know you must be there with DARPA. We'll deliver 10 times the response in your teams. We'll do this here. We'll do that there. So the guys go, oh, come on in, and go through my whole company, please.
Yeah, where the rubber meets the road for me, I guess I would say, is what we introduce is a new way of doing, and I'm using a lot of esoteric terms, a new way of doing human factors engineering. So human factors engineering, that is the study of human performance and limitations, safety and satisfaction in engineered systems.
Oh, we love that.
Yeah. So, I mean,
We love it.
yeah, for example, all major automobile companies they might call it something else, but they'll have a human factors engineering division, right? Where they're studying like the driver's comfort or all sorts of things.
Yeah.
But what we do, and at the same time, I think a lot of what goes on in terms of quantifying the effectiveness of these AI systems or robotic systems when you put them in an environment are things like, what's the bottom line? How much money are we saving? How many units are we moving? Whatever, right?
Yeah.
But what it lacks is what that approach that I was describing before, measuring that real-time interactive state. What we can do by measuring that is give you those numbers, as well as we can predict how the human is going to experience this in terms of variables. So some things we predict are subjective user assessments of trust, satisfaction with the system, those sorts of things. So our approach, it not only quantifies that bottom line sort of metric that people are after, but gives you a new way of doing human factors engineering that also simultaneously predicts the user's experience with the system. So
Is
that's the way I
that a
would.
test? Is that a test afterwards, or is that all diodes and smart this and smart that.
Yeah, well, so this gets into more of our publications and technical reports. But yeah, once we have all the data from a particular environment or study that we're doing, what we do is we run tests with that data to show that we are not only in real time predicting how the system is performing objectively, but also the user's experience of that system. For example, how their amount of trust in this robot is changing over time.
Oh, fascinating.
Interesting. This is so fascinating. Jamie, we're coming to the close of the show, and it's so many questions.
Could go on another.
I mean, another couple hours. I mean, it's so. We definitely want to track your work. Like, we want to see what you're. And I'll come down to Arizona and at some point, and I'd love to just sit and observe. If
you're right around the corner, Mike.
I am. I'm up in Scottsdale, so yeah. I keep forgetting I'm here because I'm on the road half the time. But
you need a bot.
I need a bot.
It reminds you, yeah.
But I mean, just if you had a recommendation for our listeners, like, because I mean, our audience, some are very tech savvy, some are very into this, and some are just exploring and trying to figure it out. Like, what's your calming advice? Like, okay, we're in an AI world. What would you say to somebody? Like, it's going to be okay, or it's like the guy on Braveheart, the Irish guy that's like, I'm okay. I talked to God, but you're good luck. Like, what is it for you?
I think it's going to be okay. I hope, but I'm very optimistic.
Yeah.
So when I think about the evolution of humanity and where we're at now, and maybe where we're going, I have a sort of an optimistic viewpoint that things tend to get selected that sort of promote humanity, and things that start to not do that start to fall away.
Yeah.
And there's no stopping it. It's just what the universe is.
Well, I think if you do it your way, which is that, Stanford has the Human AI Center too, which is, if we go in that direction and it's more human centric, definitely we'll be better off.
Yeah. Well, I mean, our interest is to preserve ourselves, right? I don't think we're going to embrace a technology that's going to be like Terminator. So,
well, AGI is the one that, schemes now. You probably know that. And, that's the one where they keep building it so fast that you don't quite know what the guardrails are. And they're all quirky. They get anxiety, and we've written a bunch of articles on it. They all want to be actors. It's like they all have this propensity.
I mean, yeah. Jamie, any parting words? Like, so amazing. So if any parting words for our audience?
I would love for you to come visit our facilities here. We have several chart test beds that I would like to show you that involve human robot teaming as well as human AI teaming. So one's a space challenge that is a distributed space teaming simulation. One is a distributed UAV simulation with a site at ASU and a site in Dayton, Ohio with the Air Force Research Lab. So we got a lot of cool things to play with. And that's another key point that I would say is part of this new discipline, this new area chart, right? This new science are coming up with how to study these systems. And so these test beds are crucial. And I think that's something we're going to see more and more of, are these human machine teaming test beds springing up. And I guess one other thing I would say is earlier, like I was thinking, what do my students take? What are they into? We do philosophy. So Mikhail Bakhtin is big, philosophy of the act. Nonlinear dynamical systems is an area that's important in our work. So that's from physics, computer science. We've talked about robotics, and then psychology. So
it's amazing.
That's so amazing. So where do they find you? Did you just go to ASU and Arizona State? I guess that the number one innovative university in the country, right? For 10 years in a row. I mean, just crazy.
Yeah, that's what we do. That's why I'm here. I was at Georgia Tech just a few years ago, and they brought me here, and I love it. Yeah, if you just Google my name, it should come up.
Thank you so much, Jamie. You're like we said, you're a rock star and you're a pioneer in this area, and it's so necessary and so cool. And I'm in Santa Monica, can't see you. I might actually be going back there on another project for ASU. But Michael, I'll send Mike over.
I'll come. I'll definitely
jealous.
Come. Yeah, no, I'll definitely come. Well, Jamie, I want to thank you for being on the show. To our listeners, I just want to encourage them to stay curious, stay collaborative. I mean, this is so important. Keep your eye on AI.
Stay curious, stay powerful, and stay human.
Stay human. I love that. So, Jamie, thank you again.
Thanks again, Jamie.
Thank you.
Be sure to subscribe to our podcast, either on Spotify, Podbean. Leave us a review there as well.
Share this episode with your friends, and check out the Rise of Humanness on YouTube for bonus clips.
Visit our Facebook community, our website, www.itsvucamax.com. All right, guys, we'll see you next time.
Bye-bye.
The rise of humanness in the age of AI. It's a podcast with Chris and Mike. The rise of humanness in the age of AI. Stay curious, stay human, let's rise.